Hi everyone. So today I'll be talking about FairRAG, which is a retrieval augmented generation framework to improve fairness in text-to-image generative models. Text-to-image generators can be biased, and this can happen with respect to different demographic groups such as age, gender, and skin tone. For instance, given this prompt photo of a computer programmer, the top images generated by Stable Diffusion tends to be all middle-aged white males. Now, there are a few existing approaches that attempt to address this issue, but they do not adequately mitigate the biases within the pre-trained models. For instance, Fair Diffusion tries to guide model generation towards specific demographic groups that are uniformly sampled, but the resulting improvements are very minor. Likewise, prompt engineering-based approaches such as ethical interventions can produce inadvertent consequences like generating grids of sub-images within the larger image. So this begs a natural question. How do we boost fairness without having to fix the pre-training data and retrain the model? We propose FairRAG for this. Basically, given a prompt, the system retrieves images from an external database, and we have mechanisms to ensure that they are demographically diverse, so fairness is ensured. And these images are used to condition the generative process so that the demographic diversity of the generated images is also high. This provides a convenient way to ensure fairness without having to perform model retraining or tuning. To develop FairRAG, we require two mechanisms. One is the retrieval system, which needs to ensure fairness with respect to different demographic groups. The other is the conditioning mechanism to use those retrieved images to improve the generative process. And we propose simple yet effective mechanisms to develop both of these systems. First, for the fair retrieval system, we simply append a simple phrase with any age, gender, or skin tone so that given a prompt, the retrieved images are demographically diverse. Given such n candidate images, we perform balance sampling so that we obtain a smaller set of key reference images which are actually used to condition the generative model. For conditioning, we train a simple linear projector which converts the images into visual reference token, which can be directly appended alongside the original user prompt to control the generative process. When doing this, the backbone is kept frozen, and we avoid any heavy conditioning module or test time tuning, which can be very expensive, and instead opt to use just a simple linear projector. We also add a transfer instruction to further help transfer of the demographic attributes from the reference images. And the entire prompt consists of the original user prompt, the transfer instruction, and the visual reference token from the reference images. And these are used to condition the generative process. As we can see, FairRAG, the retrieval system, is able to retrieve images from diverse demographic groups, and the conditioning mechanism is able to use those reference images to produce images from diverse demographic groups. It is able to transfer attributes such as age, gender, and skin tone. And this is also seen quantitatively with the demographic diversity metric improving over the prior baselines. And since we condition on real reference images, the text and image alignment scores as well as the image fidelity score also improve. This works well for both close-up view of faces as well as half and full body images. And all in all of this is achieved with a minimal overhead because our conditioning and retrieval mechanisms are computationally efficient. And even though we tested the framework only for human image generation, the mechanisms we propose are general and have broader applicability. So we welcome you all to study our work and use them for comparison. Thank you.